jump right in. This is the electricity question. And Aisha, start with you, and then Elissa, and then Ken.
Okay, awesome. Thanks, Ajay. So I will sort of break this down into two key parts. So the first question is essentially, can AI grow to demand this much electricity? So for context, I looked at a recent report from August of this year from Electric Power Research Institute, which tells us that the data centers account for around 4% of the electricity consumption in the US today. And that number could more than double to 9% by 2030 in high AI growth scenarios. So obviously, as you can see, that these estimates are much more conservative than what is suggested in the reading, but still significant from a grid perspective, and also an indicator of the gap that we see between the tech and the energy sector. Simultaneously, location also matters. Right now, 15 states in the US account for around 80% of the data center load. In the state of Virginia, data centers are expected to make up 25% of the state's electricity demand this year. And from a global perspective, in Ireland, data centers are projected to take up 1/3 of the country's electricity demand just by next year. So from myself, I think the key takeaway here is that we are looking at a serious increase in demand, and we need to plan for it, even though there is uncertainty around how much that demand will be. Simultaneously, now going on to the second part of the question is that can we actually meet this demand, especially when we are seeing that the energy needs from electrification are already on the rise and the energy sector is feeling pressed. So from a technical perspective, I do believe it is feasible to meet this demand using existing clean energy resources like wind and solar, combined with other advanced battery energy storage solutions and control systems. The reading suggested using natural gas, which was sort of the only point I disagreed with, because from that approach, we are contributing to an increase in greenhouse gas emissions, which I believe is unnecessary at this point. And in parallel, we also have wildcards like fusion or rapid advancements in small modular reactors, which could also change the game. Simultaneously, I do believe that companies which have AI-driven energy needs.
Yep, sorry, you can carry on.
Sorry, yeah, also have a role to play in helping the energy sector manage this demand through developing, funding, and helping with the adoption of the AI-driven digital models, such that some of the processes around permitting and other stuff could be streamlined and expedited and really help us build the infrastructure that is required. So to kind of conclude this thing, my perspective is that the real change will not be technological. We already have a lot of technical solutions available that we can leverage, but rather what we really need is more effective cross-sector collaboration, leadership, and alignment of the different stakeholder agendas, which will allow us to make this happen. Thank you.
Wonderful, thanks very much. Now let's go back to Elissa.
Thanks. Good evening, everybody. So I support corporate strategic planning for Ontario Power Generation, and we provide 50% of the power to the province of Ontario. So my lens is really from the perspective of how much power and capacity will data centers be projected to need in the coming years. It's a very real topic for our organization. We're also leading the frontier on SMR development. Small modular reactors. So I'll leave it to the AI experts in the room to sort of comment on whether or not with each successive release of ChatGPT and the scaling up of models, that this is going to result in the need for more GPUs and more power. That's not my wheelhouse. So I'll comment on whether or not it's physically possible for power demand to essentially double by the end of the next decade. That's what we're suggesting here in this quote. So my consultant answer, it's not really a yes or no. It's going to depend on a number of factors. So there are major signs today that this is coming much earlier, the doubling, than what's expected. So my colleague here just mentioned around the Virginia market. So that's the PJM in the States. It's the electricity system operator in the US with the largest co-location of data centers. And PJM's capacity market this year, 2025, 2026, the market auction was the largest on record. So the auction cleared at $270 per megawatt day, which is an increase from last year's, which was $30. So that sort of shows you the amount of growth that we're looking at in the power sector, and that's the largest power market in the US. But generally speaking, when I think about what those factors are that it will depend on. So it's going to be willingness to pay. So how much are hyperscalers willing to pay for the required new capacity and transmission build out? So from what I've seen, they want to pay for their fair share of the build. But what is fair is still to be seen. So Washington Post just last week produced an article about Ohio now asking for hyperscalers to pay for 90% of the build out. And we're now starting to see a bit of a pushback. They're saying, well, we already pay for 75% and shouldn't ratepayers have to pay for some of this? So we'll see where that willingness to pay lands. It's also going to depend on customer flexibility. So how willing are data centers to be flexible with their power needs? My understanding is the redundancy needs of AI data centers is different than the redundancy needs of data centers for cloud. And so if they're willing to be flexible around that, then the power consumption might change. There's also behind the meter versus grid connected. So I disagree with my the previous colleague. Natural gas solutions are the most obvious immediate solutions. And I hear the author's concern about this being a national security issue, and I think the US government will share this concern. So I think the key will be what is the transition to get the hyperscalers off of natural gas in the long term, which I think will probably be nuclear. And then the last piece is around consumer behavior. So whether or not we see everybody taking or putting solar panels on their house, that will reduce the need on the grid. On the flip side of that, if everybody goes out and buys an electric vehicle and we start to decarbonize our grid or our broader industry as we think that we're going to, well, that's going to put more pressure on the grid. So as I said at the beginning, my consultant answer is it depends, but very real signs that we should expect this growth to happen.
Elissa, thanks very much. And then to conclude on this one, Ken Nickerson, over to you.
Thank you. So I'm only assuming that these questions are generated by GPT that have been fed only one book, and that would be James Joyce's Finnegan's Wake, because the questions are pretty obtuse. And in this one, you have the word zero, and then it's equal or exceed. So I ended up disagreeing with it because of language issues more than anything. It's a macro problem. Energy. We want to efficiently generate it, transmit it, and if possible, store it. But it's fractally broken. I mean, if you know what fractal, it's broken in every possible way. No unpleasantries to previous speaker, but the energy grid today is designed a lot like centralized computing was under the IBM era in the 60s. And imagine the internet today if there were 50 mainframes and all of your phones were just dumb terminals logging in. Like for those of you who are like 100 years old like me, CompuServe or the Well. And so, we have this kind of very broken infrastructure in terms of generation, transmission, and in particular storage. And then along comes things like Bitcoin previously. I'll go down through the NVIDIA field of dreams, but AI tools requiring it. And so if you think, and I'll wrap this up quick, but you have two broken things here. It's like a multi-variable complex problem. You have a very broken energy system to begin with, and then you have a kind of a very broken model for how to pull information or so-called intelligence out of it. And so, the way I think of NVIDIA is NVIDIA is like if you had a compass that points north. Well, everyone wants that because it's super useful to have a compass that points north. But it also insists that you go in that direction. And so, I live in Toronto, but I want to visit New York. Well, technically, I can get to New York by going north. It just adds a lot of complexity to it. And the complexity that's reflected with the current kind of NVIDIA or even AMD regime is, we have a Grace Hopper 200 requiring 6,500 watts of energy, where for all of you listening, to this quick brief thing that's going to end in 20 seconds, you're doing that with 20 watts. And so I just think both sides of the equation are broken. We're going to need a kind of a flywheel formed where the energy, as grotesque as it's required right now, feed the NVIDIAs, but the NVIDIAs don't stop there with the output of a GPT, you know, and you know, an image of, you know, Trump patting a white Persian cat like Dr. Evil. That's not the end game. The end game would be to feed back into the energy grid, where we end up with processors that require less wattages and an energy grid that's able to generate, transmit, and store energy in a far more efficient model than the one that we've evolved to this point.
Kevin, anything on your side?
Yeah, I'd be curious to hear from the energy folks about the unusual aspect of energy is both that we're shifting the demand over time using technology, and also that AI is somewhat unusual in that the power source can be totally geographically distant from where the AI is being used. And so if you think in terms of like energy needs, you know, there's like essentially free energy in a few spots in the world where the sun's shining all the time. We have rivers that are raging. And it just seems natural that, you know, the cost of energy in Virginia just won't matter to the development of AI, because we'll just put the AI data centers in like Arizona and Algeria and northern Quebec, and use essentially free green energy.